Do you know about hybridization? Yes, it is one of the most weird topics, one of the most toughest topic. But today we are going to liberalize the topic by giving you a very simple shortcut. You can just say the hybridization of any molecule or any of the complex ion by just seeing the molecular formula of that particular structure C. So according to our syllabus, what is the hybridization of CH4? You have by hearted or you have remembered this a lot of times. It is sp3 hybridization. So how can you explain this sp3 hybridization? Say carbon, it has 4 outermost electrons, and the 4 outermost electrons are 2s, 2p, 2px, 2py, 2pz. All these atomic orbitals mix together to form a tetrahedral shape. So you have by-hearted or memorized this particular topic in very tough manner. But here is a simple trick. But the condition is you should know the number of valence electrons of each and every element participating in the hybridization. So 1a group elements have 1 valence electron, 2a group elements will have 2 valence electrons, 3a group 3 valence electrons, 4a group 4 valence electrons, 5a group 5, 6a group 6, 7a group 7, 8a group 8. So these are number of valence electrons, you should remember these, and you should also remember the element belongs to which group. Earlier we have discussed the shortcuts. By using the shortcuts you can remember which elements belongs to which group, and by this you can remember which group has number of valence, how many number of valence electrons. See here we have carbon. We have carbon here. Carbon belongs to 4th A group element. Carbon belongs to 4th A group elements. So the number of valence electrons will be 4 plus. Here we have hydrogen. There are 4 hydrogens in the methane molecule. So 4 into each hydrogen will have 1 outermost electron because it belongs to 1A group element. So 4 into 1. So the answer is 4 plus 4, 8. So this is the total number of valence electrons in a molecule. Here it is important. Here we are calculating the total number of valence electrons in one molecule of CH4. So the total number is 8. If the answer is between 2 to 8, you should divide this particular answer with 2. If the number of valence electrons in a molecule is between 9 to 56, then you should divide it with 8. If the value is greater than 56, then you should divide it with 18. So here our answer is 8. So 8 means it belongs to first case. So we should divide 8 with 2. So 8 divided by 2, nothing but 4. So what is the possibility of having 4 orbitals? Here we got the answer, number of hybrid orbitals. Okay, or else the number of orbitals which are participating in the hybridization. Remember that the number of orbitals which are participating in the hybridization is always equal to the orbitals in the newly formed hybrid orbital. Okay, so here the answer is 4. The single and only one probability of having 4 lobes or 4 orbitals is sp3. See, 1s and 3p. 1 plus 3, 4. The answer is 4. Similarly, if you consider any of the molecule or else any of the complex ion, say consider another example of water. Here we have 2 hydrogens, it means 2 into 1 as hydrogen belongs to 1a group, and oxygen belongs to 60a group. Okay, so 60a group in the sense the outermost electrons will be 6 plus 6, 2 into 1 2 plus 6, the answer is 8. Again it is 8, it comes to first case, so divided by 2 we will cancel out, we will get 4, and 4 is nothing but sp3 here. If you observe any water molecule, it will be written as like this. So what are these? What are these dots? These dots represents number of lone pairs. So what are these? These are number of lone pairs. We can calculate the number of lone pairs by using the same trick. We cannot do anything special or anything deviated from this particular shortcut. Just we have got the answer 4 here, and the central atom is having 6 outermost electrons. So 6 minus 4 equal to 2. So we have 2 lone pairs on oxygen atom in a water molecule. So this is very simple shortcut. You can apply it for any of the ions. If you consider sulfate ion, SO4 2 minus, if you consider SO4 2 minus, so what is the group number of sulfur? Obviously the same group which oxygen belongs to, it is 6. It means sulfur has 6 valence electrons, and oxygen, there are 4 oxygens with 6 outermost electrons each. So 6 plus 4 into 6 plus, here we have minus 2. It means we have to put plus 2 here. If you have plus 2, we have to put minus 2 here. Okay, so 6 plus 24 plus 2, the answer is 32. So 32 is second case divided by 8. It is also in sp3 hybridization, so sulfate ion will be in sp3 hybridization. In the similar way, if you consider any other say if you consider some BeCl2, if you consider BeCl2, beryllium chloride, the beryllium belongs to second A group, so the valence electrons are 2, and chlorine belongs to 7th A group. Here we have 2 chlorines, so 2 into each chlorine will have 7 valence electrons, so 2 plus 2 into 7, it is 2 plus 14, the answer is 16. 16 comes to second group, second case, so divided by 8, if you cancel out you will get 2, so beryllium chloride will be in sp hybridization. Here 2 represents 1s and 1p. So this is a very simple shortcut. Will be there any lone pairs on beryllium chloride? On beryllium, no, because 2 minus 2, it is 0. So we have 0 lone pairs on the beryllium chloride. In the similar way, if you consider any other, say boron trifluoride, this belongs to 3A group element. So the valence electrons are 3 plus, we have 3 fluorines here into each fluorine has 7 valence electrons because it belongs to 7th A group. So 7, 3 plus 21, it is 24, and it belongs to second case divided by 8. Okay, so if you cancel out we will get 3 in the sense sp2, 1s and 2p, so total 3. Next, 3 minus 3, 0. So we will have no lone pairs on the boron atom in beryllium trifluoride molecule. Okay, so this is a very simple shortcut which makes you to answer the bits during your exams, but you should not write the theoretical part in this manner. You should completely explain the questions which were asked in the theory part, like 4 marks or 2 marks, like that. If you asked a hybridization for bits or any in competitive exams, you can use the shortcuts and you can easily tell the answer. Thank you.